Hello everyone, I am Sandeep. I am here to discuss about merge sort. Input will be list of n elements and the output will be a new list containing the same elements in the sorted order. Let us understand about the algorithm. If less than two elements return a copy of the list, then sort the first half using the merge sort. Then sort the second half using merge sort. Merge the two sorted halves to obtain the final sorted array. Let us understand about merge outline. The input will be two lists A and B already sorted, and the output will be a new list containing the elements of A and B merged together in sorted order. The algorithm will be create an empty list C, set index A and index B to 0, while index A is less than the length of A and index B is less than the length of B. Add the smaller index of A and the B to the end of C. Increment the index of the list with one element. Increment the index of the list with a smaller element. If any indexes are left over in A or B, add them to the end of C in order and return C. Let us understand about filling in the details of merge. Add the smaller of A and B to the end of C and increment the index of the list with the smaller element. If index of A is less than index of B, then do the following. Append index of A to the end of C. Add 1 to index A. Otherwise, do the following. Append index B to the end of C. Add 1 to index B. Let us understand about filling in the details of merge. If any elements are left over in A or B, add them to the end of C in order. If index of A is less than the length of list A, then append all the remaining elements of list A to the end of list C in order. Otherwise, append all the remaining elements of list B, if any, to the end of list C in order. This is one of the example of merge sort. This left side of it is list A and the center one is list B and right one is list C. It will compare the first elements of both lists, which will be smaller. It will be included in list C, and it compares again. It will be incremented by one in the list A, and it will be compared again with the list B of the first element, and it goes on like that. This is the second example for merge sort. Let us analyze the efficiency. Constant time operations, comparing value and appending elements to the output. If you merge two lists of size I by 2 into one new list of size I, what is the maximum number of appends that you must do? And what is the maximum of number of comparisons? Example, say if we are merging two pairs of two elements list with eight appends for eight elements. If you have a group of list to be merged pairwise and the total number of elements in the whole group is n, the total number of appends will be n. Worst case number comparisons n by 2 or less, but still O of n will be the time complexity. Let us calculate how many merges we have done so far. We saw that each group of merges of n elements take O of n time operations. How many times do we have to merge n elements to go from n groups of size 1 to one group of size n? Let us understand that with the example. Merge sort on 32 elements. Break down the groups of size 1. That will be the base case. Merge 32 lists of size 1 into 16 lists of size 2 and 16 lists of size 2 into 8 lists of size 4, 8 lists of size 4 into 4 lists of size 8, 4 lists of size 8 into 2 lists of size 16, and 2 lists of size 16 into 1 list of size 32. That will take log n merges of n elements. Putting it all together, it takes n appends to merge all pairs to the next higher level. Multiply multiply the number of levels by the number of appends per level. The total number of elements per level is always n. It takes log n merges to go from group of size 1 to a single group of size n. In the worst case, merge sort requires O of n log n time to sort with an array with n elements. The number of operations and the order of complexity is given below. If the number of operations are n log n and the order of complexity will be O of log n, for every number of operations given below, the order of the complexity will be O of n log n.